Part B says express the right side of the formula in simplest form. So we have the formula here, and what we're going to do is we're just going to clear out the denominator inside the denominator, or the embedded denominator. So I'm going to multiply the bottom by R1 and also the top by R1. And I'm going to multiply the bottom by R2 and the top by R2 to clear out that denominator, and then the bottom by R3 and the top by R3 to clear out that denominator. Okay, so once we've done that, we can cancel out some factors. So this times these cancel out, and what we're going to be left with in the denominator, hold on, let me just write out the numerator here first again. So let's work out the numerator first so that we know what's happening in the numerator. So R1 times R2 times R3, none of these will cancel out. Okay, in the denominator, we have some things canceling. So we have the R1s canceling. So we're going to be left with the R2 times R3 for the first part, plus the R2s cancel here. So we're going to be left with R1 times R3, plus we're going to have the R3s cancel out. So we're left with R1 times R2. Okay, so this would be the simplified form of that right-hand formula. And so the formula now is we're just going to multiply the resistances together in the numerator, and then use this sum of the partial products in the denominator. So we're going to apply that in part C. So part C, we're just going to plug in our values. Our R2, R1, R2, R3 were 2, 3, 4. So just plugging that in. So my total resistance is now going to be equal to, it's going to be 2 times 3 times 4 in the numerator. And then in the denominator, we're going to have 3 times 4 plus, we're going to have 2 times 4 plus, we're going to have 2 times 3. Okay, and this works out to be, and this is what we saw in this step in the previous question, and we end up with 24 over 26, which simplifies to 12 over 13. And that's ohms, and that's the same solution that we had here.